This tutorial is about opaque plastics with different surface finishes. Minimalistic imperfections will be applied using the real-scale cubic UV projection method, so you won't need to create UV coordinates via UV unwrapping. We'll use an evaluation scene with HDR emitter lighting, a product photography camera with depth of field, and a floor plane. But you can skip that part if you have your own ideas. Once you understood how the materials work like they do, you can easily swap color and refractive index for any other opaque plastic material. So let's look at the finished results. ABS or acrylonitrile butadiene styrene matte, ABS matte with scratches, ABS textured, ABS shiny, and ABS shiny with scratches and dust. Make sure that all your parts are properly detailed, because you can't render what doesn't exist. Correct draft angles, wall thickness and fillets in the appropriate places make a huge difference. Open Maxwell Studio and load a standard beginner layout using the Windows menu. Load the materials test scene and change the perspective viewport to textured decal mode, so you can see the photo studio lights and floor plane textures. This is a classic 4-point lighting setup that lets you appraise material properties rather well, that provides reflections and allows you to create different photographic moods with multi-light without having to re-render. The camera is set to HD format, so you have a large image to examine materials in detail. Using a long lens eliminates perspective distortion, and a suitably high f-stop provides a nice depth of field. Instead of pushing the lights to unrealistically high values, simply adjust the ISO and shutter speed to change the overall brightness, just like you would using a physical camera. Import the brick and minifigure OBJs and orient them either numerically or using the W and I keys like in Maya. Reset the transformations you applied so they won't interfere with texture mapping. Right-click in the viewport to set the focus. Activate the interactive renderer to get an idea about the lighting and depth of field of the scene. ABS Matte. Right-click in the Materials list and select New Custom. Set the BSDF's reflectance 0 color to 209/27/17 and the reflectance 90 color to 0. Right-click in the Material Editor and select Add BSDF. Drag the reflectance 0 color over from the previous BSDF and set the reflectance 90 color to white. Set the roughness to 34, the refractive index ND to 1.54 and keep the extinction coefficient K at 0. You can find refractive indices and extinction coefficients for all kinds of substances online. Set the weight of the first BSDF to 70 and the weight of the second to 30%. In the Material Editor's Preview section, load the symbol scene and in the options set the sampling level to 20 and render time to 5 minutes. Then click Update. If you want to save a material for future use, you want an accurate preview icon so you or your colleagues know exactly what a material looks like. Because of the size of the symbol and its baked-in UV coordinates, and your objects having different dimensions and wall thicknesses, it is best to use relative texture mapping method and keep repeat and bump strength as shown, not for the render, but only the preview icon. Drag the material onto bricks and minifigure, then click Render. ABS Matte with scratches. Right-click in the Materials list and select Clone Material to make a duplicate. Right-click in the Material Editor and select Add BSDF. Drag the reflectance 0 color over from the previous BSDF and set the reflectance 90 color to acid green for the moment. Change roughness to 70, set ND to 1.54 and keep K at 0. Activate R2 and set the first factor to 70, then click Update. R2 lets the reflectance 90 color's visibility depend on the viewing angle, and soft-touch materials, textiles like velvet, metallic coatings or car paints require this feature. Now change the reflectance 90 color from acid green to white, what it should be. It will make the matte and scratched ABS plastic look duller. In the material's global properties, load the noise micro-scratches N texture into the global bump slot and repeat it 2 by 2 for the moment, so it shows up in the material preview icon. Set the bump strength to 100 for now and activate normal mapping. Then click Update. Change the noise micro scratches and texture mapping method to meters and the size to 2.5 by 2.5 centimeters, because this is what the texture represents in the real world. Reduce the bump strength to 53 and drag the material onto bricks and minifigure. You will get an alert message. So what is that telling you? When you set a texture's mapping method to meters and then use real-world texture dimensions, the object's UV projector must change accordingly. So select Lego bricks and minifigure, go to Geometry in Object Parameters, choose Cubic as projection method and click Normalize, then click Render. ABS Textured. Right-click in the Materials list and select Clone Material to make a duplicate. Right-click in the Material Editor and delete the R2 BSDF. Lower the roughness to 26 and set anisotropy to 50%. Load the noise anisotropy flakes AA texture into the angle slot and repeat it 0.5 by 0.5 for the moment, so it shows up in the material preview icon. Anisotropy will spread the reflections according to the texture, also required for brushed metals or textiles. Drag the texture over into the material's global bump slot and use the same repeat to match. Set the bump strength to 8 for now and deactivate normal mapping, because this is a regular grayscale texture. Then click Update. Reduce the global bump strength to 0.4. Set both bump and angle texture mapping methods to meters and the size to 10 by 10 centimeters, because this is what the texture represents in the real world. Drag the material onto bricks and minifigure, then click Render. ABS Shiny. Right-click in the Materials list and select New Custom. Set the Reflectance 0 color to 27, 190, 189 and the Reflectance 90 color to 0. Right-click in the material editor and select Add BSDF. Drag the Reflectance 0 color over from the previous BSDF and set the Reflectance 90 color to white. Set Roughness to 7, set ND to 1.54 and keep K at 0. Activate Force Fresnel to maintain bright reflections for all viewing angles. Set the weight of the first BSDF to 70 and the weight of the second to 30%, then click Update. Drag the material onto bricks and minifigure, then click Render. ABS shiny with scratches and dust. Right-click in the Materials list and select Clone Material to make a duplicate. Load Gun Scratches 001 Overlay var 26K into both BSDF bump slots and repeat it 2x2 for now, so it shows up in the Material Preview icon. Set the bump strength to 5 for the moment. Right-click in the Material Editor and select Add Layer. Set the Reflectance 0 color to 60, 20, 150, or whatever dust color you prefer, and the Reflectance 90 color to 0. To apply dust particles only in some places, load Dust Small 002 Overlay 6K into the new Layers Opacity slot and repeat it 2x2 for now, so it shows up in the Material Preview icon. Set the layer opacity to 80% to slightly reduce the dust visibility. Drag the texture to the global bump slot, repeat it 2x2 to match. Set the bump strength to 5 for the moment, then click Update. Change both BSDF's bump strength to 0.6, both texture mapping methods to meters, and the size to 10 by 10 centimeters, because this is what the texture represents in the real world. Change the global bump strength to 0.4, both bump and opacity texture mapping methods to meters, and their size to 15 by 15 centimeters, for the reasons mentioned before. Drag the material onto bricks and minifigure, and then click Render. And now it's your turn. Thank you for watching and listening.